this problem is about largest possible volume. So amount of material is given and the base is square. So we have open top box like this, and for the given amount of material, we want to maximize the volume of the box. Okay, so we are also interested in, we are interested in two things, volume and area. So if you open this box, you will get picture like that, base, and then 4 sides. Like that. Okay, so in the first step, we read the problem and draw a diagram like this. In the second step, you introduce letters. Well, let us use X for the side of the base. Now that the base is square, you can use X again, and then Y for the height. So we have labeling, X for the base, Y for the side, like that. Okay, so volume is simply base and then height. This is a volume, and then we are also interested in area. The base will give you x squared, and then each side has area x times y, but we need 4 copies of x times y. So as you see, we have functions in 2 variables, and we want to maximize this function. Now that this function has 2 variables, we want to eliminate one of them. You can use this area because the area is given by 7,500. So we have identity. Using this, you can eliminate x or y. It seems better to eliminate y. If you solve this identity for y, you will get rid of this y. So this says, well, if you solve this for y, y is 7,500 minus x squared over this. And then you replace y by that, then you will get one function solely in x. So volume is going to be x squared times y, which is 7,500 minus x squared over 4x. Well, after canceling one copy of x, we have x times quadratic function. Well, this is 1 over 4 is just a scalar. Basically, we have quadratic function. So we can take derivative. You can distribute 1 by 1, or you can use product rule. If you distribute, we have 1/4 times 7,500x minus x cubed. So derivative of this quadratic function is 1/4. Derivative of this minus 3x squared. Good. And we are interested in when this becomes 0. So v prime becomes 0 if this expression becomes 0. Well, 75 is a huge number, but this is a multiple of 3. When you divide it by 3, we have 2,500. So this becomes 0 if and only if x squared is 2,500. Or x is, well, this is square of 50. Good. So we know v prime becomes 0 when x equals 50. So we have two cases, concave up, concave downward. Well, we want to maximize this volume, so we want this is the case. So that's why we need to use one-off derivative test. So first derivative test or second derivative test. If you use first derivative test, you want to make sure v prime change its sign when x equals to 50. So here we have v prime. So basically we want this to be 50. So we want to make sure that before 50 we have positive slope, and then after 50 we have negative slope. That's what we want. For the first derivative test, we choose any number, one less than 50, one larger than 50. So v prime 10 is, you plug that, so we have 1/4 some number minus 3, 10 squared. Of course, this is just 300. Definitely this is positive. And you choose any number larger than 50, v prime, say 60, is 1/4 7,500 minus 3 times 6 squared. Well, 60 squared is 3,600. When you triple, of course, this is greater than 10,000. Of course, we have negative. That's it. We have verified that v prime has changed this sign from positive to negative. So this is the case. By this test, we see that v volume has the maximum when our x is 50. Okay, so the largest possible volume is v of 50. You plug that into this volume. So we have 1/4 minus 50 cubed. Yeah. So you calculate this to find the maximum, and that will give you the maximum volume.